Hi, this is Mrs. Jackson. This is Chapter 2, Section 4, Part 4. It's the last video in this section on imaginary and complex numbers. In this section, we're going to be factoring the difference of two perfect squares and also factoring the sum of two perfect squares. So let's get started. First, let's take a look at factoring the difference of two squares, the difference of two squares. So notice that 4x squared is a perfect square and 25 is a perfect square. We can factor that into the product of two binomials in the following way. So this is equal to 2x, and I'm going to close this up, and I'm going to put 2x over here. So you can see if we distribute 2x times 2x is going to give us that 4x squared. And then 25, really negative 25, is going to arise from positive 5 times negative 5. Now what happened to the middle term? When we multiply two binomials together, normally we would get a middle term, we'd get a trinomial out. But let's see what happens here. From the previous video, we saw that when we multiplied complex conjugates together, that middle term canceled. So what we would call 2x plus 5 times 2x minus 5, these are real conjugates. There's no imaginary numbers here. I'm going to go ahead and distribute everything just to show you that middle term will cancel. We've got 4x squared minus 10x plus 10x minus 25. And we can see that these middle terms here are going to reduce to 0. So this is a case, and you've never probably heard the expression, but just like in the previous video when we talked about complex conjugates, these are real conjugates. And it's the only time when you multiply two binomials together where you're going to end up with another binomial out because of that cancellation. Now in the next example, I purposefully gave you two non-perfect squares, but you can see that these are both even numbers, and so you can go ahead and factor out a 2 right away. So here I can have 4y squared minus 9. And here now you see two perfect squares. So I can keep going with that. I've already got my 2 out, and I've got the difference of two perfect squares. So I've got 2y times 2y is going to give me the 4y squared, and positive 3 times the negative 3. These are real conjugates. That middle term is going to cancel, and so right here we've completely factored 8y squared minus 18 into 3 distinct factors, and they are all real. Let's look by comparison how we would factor the sum of two squares. So down here I've got 4x squared plus 25. This looks remarkably like our first example up here, except now it's a sum. Now both of these terms are perfect squares, and let's go ahead and see what happens if I end up going with those real conjugates. I'm going to end up with the difference. I'm going to end up with the difference. So if I said 2x plus 5 times 2x minus 5, I'm going to end up with the difference here, not the sum. So we're going to use our knowledge of imaginary numbers and I squared to rewrite this. So I'm going to rewrite this as 4x squared minus a negative 25. Now subtracting a negative number is the same thing as addition. And I'm going to rewrite that negative 25 as 25 times a negative 1. We know from our knowledge of imaginary numbers that I squared equals negative 1. So I'm going to replace that negative 1 with I squared. So I've got 4x squared minus 25. I'm replacing that negative 1 with I squared. Now I have the difference of two perfect squares. And now I can factor out that difference of two perfect squares. I've got 2x times 2x is my 4x squared plus 5i and minus 5i. So what we have here is when we have the sum of two perfect squares, the only way I can factor that is with complex conjugates. So instead of real conjugates, we have complex conjugates. Remember, complex conjugates are when the real part are identical and the imaginary part are opposite. Okay, let's go ahead and try one more example here. I can see that both of these both these two terms are evenly divisible by 2. And now I see I have the sum of two perfect squares. So I'm going to rewrite that. I'm going to say 2 times 4y squared minus a negative 9. I'll put that in like little parentheses here. I'm going to write that as 2 times 4y squared minus 9 times a negative 1. That's 2 times 4y squared minus negative 1 equals I squared. So I've got minus 9 I squared. And now I have the difference of two perfect squares. So I'm going to say 2y times 2y gives me my 4y squared plus 3i minus 3i gives me my negative 9i squared. Again, we end up with complex conjugates. So the summary here, the takeaway, is that when I am going to factor out the difference, in other words, subtraction, the difference of two perfect squares, I end up with real conjugates out. Likewise, when I factor the sum of two perfect squares, I'm going to end up with complex conjugates out. Okay, this is the conclusion of this section on imaginary and complex numbers. Thanks for listening. Hope this helps.